Today we're going to move on to arithmetic sequences and partial sums. It tells us here that a sequence whose consecutive terms have a common difference is called an arithmetic sequence. This is the important part right here, a common difference. So the definition given here is a sequence is arithmetic if the differences between consecutive terms are the same. So those first differences are the same. So the sequence A1, A2, A3, A4, and so on is arithmetic if there is a number D such that A2 minus A1 equals A3 minus A2 equals D. The number D is the common difference. To find that difference, we take our second term and subtract our first term. That's going to give us D. So those first differences are going to be our D value. The nth term of the arithmetic sequence is an explicit formula in the form of A sub n equals A sub 1 plus n minus 1 times D. Now that looks a little bit scary there, but it's just a linear equation. That's basically what it's telling us. Our first difference is being constant is linear. And that D value is the slope that we're looking for. So sometimes you have seen it. C, which is our constant, is equal to A1 minus D. So if we distributed this D here, and we added the A1 and the negative 1D when you distributed, that C would look like this. And our equation would be A sub n is equal to dn plus C, which is y equals mx plus b. Our D is our slope and our C is our y-intercept. So that's all this is just written a little differently. All right, so let's talk about these terms now. It says find the formula for the nth root of the arithmetic sequence whose common difference is 5 and whose first term is -1. So our first term is -1. So it's giving us this point right here, and it's telling us that our common difference is 5. So then we know D is equal to 5. So we're going to go ahead and write the formula, and we will go ahead and write it with both of them. So we'll start with the formula they just gave us here. A to the n is equal to A1, which is our first term. So that's going to be -1 plus n, which we said that's our first term, -1 times our D value, which we said is 5. Now we're going to go ahead and distribute. So we distribute the 5 there, and we get 5n minus 5. I combine my like terms. So -1 and -5 give us a -6. And so there is our simplified equation. I'll go ahead and show you because you've seen the other way in Algebra 1. So we would plug in our 5 for our D and plus C. So I'm showing you this one right here. We have this one point. -1 was the term when it was the first term. So I put 1 for the n plus C. I subtract this 5 to get it to the other side, and I get -6 is equal to C. So we get A sub n of 5n minus 6. So there's another way of writing it. All right, for number 2, it says find the formula for the nth term of the following sequence, and they give us all of these terms here. As I look at them, this went up by 4, up by 4. Every single one of these went up by 4. Our first differences are constant, so I know it's linear. And so we know that the D value is 4, because those are the differences. Our first term here is -3. So to write our equation, we get A sub n, -3 is our A1, and D is 4. We distribute, and we combine our like terms. And there is our formula for this sequence. All right, the next one says write a formula for the positive 2-digit numbers ending in 4. So the first thing I need to do is think about those numbers. There is our positive values that are 2 digits and end in 4. 14, 24, 34, 44, 54. These have a common difference of 10. So our D value would be 10 in this case. Our A1 is 14. And so we get A sub n is equal to 14 plus n minus 1 times D, which is 10. I distribute. I combine my like terms. And there is my formula. All right, for this one here, it says the fourth term of an arithmetic sequence is 20 and the 13th term is 65. Write the first 5 terms of the sequence. So what they've done here is they've given us 2 points. So we've got 4 and 20 and 13 and 65. Those are the 2 points from our arithmetic sequence. Now that we have those 2 points, we can find D by finding that difference. So we would do 65 minus 20 over 13 minus 4. That gives us 45 over 9, which is 5. Again, just like the slope, you've done this before, the difference in your y's over the difference in your x's is going to give you that constant difference, constant common difference, which is 5. Now, to find the other values, we go ahead and we write our equation. I'm going to go ahead and do it with the linear one now. So 20 is my final, 5 is my D, n would be 4, and then looking for my constant. I subtract this 20, and so we get 0 equals the constant. So our formula here would just be 5n since there's no constant. So to find the first 5 terms, I use this, and that's a pretty easy one. Our first term would be 5, our second one would be 10, 15, 20, 25. There's the first 5 terms because when I plug in 1 here, I multiply that, I get 5. 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and 5 times 5 is 25. Notice that we found that the fourth one was 20, which is what they initially gave us. If we kept going to the 13th one, we would find 65. All right, what is the number of terms in the sequence 4, 1, -2, -5, and all the way to -101? This is another way of asking kind of the same question. The first thing I do here is find my differences, and I see that this is going down by -3 each time. So my D value is -3. I'm going to go ahead and write my equation. Again, you can use the formula that was given to you up there of A sub 1 plus n minus 1 times D, or you can use the linear equation you've used in the past. So we get 3 here, and I'm going to plug in 4 for my final one, and that's my first term in the sequence, so that is times 1 plus C. I subtract my 3, and so we get 1 is equal to C. Sorry about that, I missed a sign here. Let's try that again. That was a -3 because the D value is -3. So I am going to add 3 to get it to the other side. So 7 is equal to C. So my formula here for this pattern is going to be -3n plus 7. Now that doesn't answer the question. This gives me a formula to find all of my sequence values, but it does not answer the question, because the question here is, what is the number of terms in the sequence 4, 1, -2, -5, ... all the way up to -101. So we need to know what term this number is, because that's going to tell me the number of terms. So I plug in -101 for the a sub n, and now all we have to do is solve. So we would subtract 7, and I've run out of space, so I'm going to go ahead and come over here. And so I get -108 is equal to -3n. I divide by -3. And so my n value is 36. So there are 36 terms in this sequence. This is a bunch of different ways that they can ask you the questions, again, with these formulas that we're going through. So just make sure you're reading those questions carefully. Write a formula for the positive. We already did that one. All right. In 1950, the average cost of a loaf of bread was 14 cents. This amount has increased by approximately 3 cents yearly. How much should you expect to pay for a loaf of bread in 1999? So in this case, they're giving you the information very similar to that linear equation. It tells you that the average cost of loaf of bread at that point was 14 cents, and it is increasing by 3 cents yearly. So that would be 0.03 times n. That's what it's going up every term, and it started with 14 cents. Now we're going from 1950 to 1999. And so that is 49 years. So we would plug in 49 for the n. And we get 0.03 times 49 plus 0.14 is $1.61. That's how much they would expect to pay for a loaf of bread. All right. When finding the sum, use alpha window number 2. You will need the number of terms and the formula. No need to simplify. So it says, find the 150th partial sum of the arithmetic sequence 5, 16, 27, 38, and 49. We need our differences because that's what we use to write the equation. So in this case, it is going up by 11 each time. So the D value is 11. My first term is equal to 5. So we write our equation. My first term is 5. And we're going to use this formula here this time. Or you could use the other one, whatever you're more comfortable with. We distribute the 11. We combine our like terms. And so we get A sub n is equal to 11n minus 6. And so for the partial sum, we write the sigma. I is going to be equal to 1. It is going to go up to 150 because we're asking for the 150th partial sum. And then our sequence is 11n minus 6. So we've combined what we learned last time with what we've learned this time. This is the partial sum for the sigma. That's finding our arithmetic sequence. All right, find the sum of the two-digit multiples of 3. So multiples of 3 that are 2 digits would be 12, 15, 18, and so on, all the way up to 99. Because it says 2 digits, we know we don't want to go above 99 because that would be 3 digits. Now I need the number of terms and I need the equation. So the difference here is 3. So the D value is 3. Our first term is 12. So when we write this, we get 12 plus n minus 1 times 3. I combine my like terms. And so there is our equation. Now to figure out what term number this is, because remember when we write the sum, we need our starting and we also need our ending point. So I need to know how many terms are in this sequence so that I can write that here. And then my formula goes in the front. So I set my 99 equal to 3n plus 9. I subtract the 9 and divide by 3. So there are 30 terms in that sequence, so we would put 30 here. Just as a quick reminder to put this in the calculator because we did not find the actual value of that sum. We just wrote the sum. You can go to your calculator. Alpha window takes you to summation. You go up to the top and put your final, what partial sum you want, and then you put in your formula. And so that's 123,675. Now, if you're trying to be quick on a test and you don't want to write all of that out again, you can use the copy and paste feature. So use your arrow to go up there and highlight it, hit enter, and it will copy the entire thing for you. And then you just have to change what you want to change. So right here, I can change this to be 30, and then I can do 3x plus 9. And so that gives us 1665 for the second one. All right, for our next one here says, consider a job with a starting salary of $32,500 and an annual raise of $2,500. Determine the total compensation from the company through 6 full years of employment. All right, so our A1 is equal to 32,500. Our D is equal to 2,500. That's what it's increasing by each year. That's what our starting point was. To write our equation, I do my starting point plus n minus 1 times D, which is 2,500. I combine like terms. And so there is our sequence. While we're here, I'll go ahead and show you a way to list out all of the values in a sequence if you're interested. You can hit second stat to go to the list part and go to ops and then sequence. And then you can put in your equation. So I can put the 2,500 x plus 30,000. X is my variable. and I want 6 full years. So I would go 1 through 6. And that puts that there. And then when I hit enter, it gives me all of the different values there for each year of employment. So for that second year, it's going to be 32,500. For the third year, it's going to be 3,500 and so on. All right, so now we put that in the calculator for the summation and we hit enter. And so her total compensation would be $232,500. That's how much she's going to have after the 6 years in pay. All right, for our last problem, it tells us a formal garden has shrubs planted inside a grid consisting of 21 rows. The first row contains 15 shrubs, excuse me. The second contains 18 shrubs and the third 21. So in our set here, we have 15, 18, and 21. This is my first, second, and third. The difference between these is 3. So our D is equal to 3. That's our common differences. So the first thing I'm going to do is write my equation here. And so 15 is my first one, so I would plug in a 1 for the end there. I subtract 3 and I get 12 is equal to C. And you can use either one of the formulas. We will be providing this formula on the test, so keep that in mind. You can use this formula each time and then simplify it. All right, so our equation here is 3n plus 12. Now, it says find the number of shrubs in the 9th row. So I would want to find A sub 9, and I would do that by plugging I'd plug in 9 for the N. So we get 3 times 9 plus 12, which is equal to 39. So there would be 39 shrubs in the 9th row. Then it says find the sum of the rows. And so that's where we want to use our sigma. We are starting at 1. We are finishing with 21 rows. And our formula is 3n plus 12. We put that into our calculator. And you can find each one of the terms and add them, but this is way easier for you to do. And so there it is with 945. So we would have 945 shrubs in total. And that is arithmetic sequences.